Bismillahirrahmanirrahim. Welcome dear students. This is Climate Responsive Design, subject 3672 and lecture number 3, the cool climate and the building context. So I'll be going through this table of contents. As you can see on the left hand side, that will be the nature of cold climates will be explored, the cold climate modification strategies, the rural, urban and suburban context will be explored. So this will be the lecture number 3 of the 3672 subject, climate responsive design. The nature of cold climate, as you can see in the pictures, is something which is depicting what kind of a nature of the cold climates are. Some of their parameters can be seen in the next slide, but this is how it appears. The right one picture on the right top side is that of a local hill station called Murray, close to Islamabad. These are also some of the pictures from some other uh, high altitude areas where the cold climates exist. So the nature of cold climate, these zones are located at high altitudes. The temperature ranges between 20 degrees Celsius to around 30 degrees Celsius in summers. The temperature ranges between -3 degrees Celsius to 8 degrees Celsius in winters, and sometimes even goes beyond -3 to -6, 7, 8, and 10 and 12, depending upon the closest context. While we are talking about -3 degrees Celsius to 8 degrees Celsius in winters, this is primarily related with some of the major areas in Pakistan, but this may go beyond like -10 degrees centigrade in some of the extreme areas. In summers, they have ample amount of moderate rain, and in winters have moderate rainfall to a snow season. Humidity is comparatively low in these regions. Survival conditions in winters may become hard and harsh because of the snow and because of the lack of accessibility and other allied heating system mechanisms and supply of food. So these are some of the major parameters. As you can see, in this map of Pakistan, the highlighted blue areas are some of those areas which falls into the cold climate region, which mainly includes northern half of Azad Kashmir, Gilgit-Baltistan, extreme northern Punjab, northern half of Khyber Pakhtunkhwa province, and northern Balochistan. Has been mainly marked as some of those areas in which cold climate exists. So some of the major parameters which are devised in the climate modification strategies is building to have slopy roofs. Now, why do we have slopy roofs? The basic reason is to let the snow and the rain trickle down, and they should not accumulate on the roof, because with accumulation of water through rain, precipitation, or of snow is going to result into increasing the weight of the rooftop, and hence may lead to collapse or may lead to some other issues. Buildings will have slopy roofs, as already discussed in the previous lectures. There will be some eaves and there will be some areas, and these slopes are going to help us down in managing two forms of functions. The first one to trickle down and let the snow and the water flow down, and it will not be stacked above. And this central space, which is between the false ceiling and the roof, which is in a triangulated shape or in a tapered shape, is going to have a gap, and this gap is going to help us insulate the interior surfaces from the external environment. Building will have thicker walls with insulation, so that with the help of these, the warmth inside the room can be retained. They usually are developed with the help of bricks or block masonry with insulations, or even with stones and trombe walls, or even with the help of clay or mud bricks. But depending upon how they are going to be utilized, it has to be baseline that their structural stability as well as the insulation values are higher, so that they can be retained. Buildings will have thicker walls with insulation. As you can see, there can be like cavity in between, and can be insulation and water barriers to ensure that the flow of water can be restricted. As you can see in the upper one, these have been developed using the trombe wall based technologies, or utilizing the rammed earth based technologies and alternates, and then it can be compressed and are going to have thicker walls, so that the value of R or U values, basically the transmittance of heat, can be reduced and can be retained inside of the buildings. All right, bedrooms on south and west side should be placed so that they can have exposed maximum area to the sunlight during the winters, and can have some warmth inside the spaces, and can be kept with least energy demand towards a comfortable living space. Bedrooms on southwest side. Now, in the hotter climate regions, usually it is preferred to have these balconies, so that it can be acting as a shading device for the lower windows. But in the cold climates, This method is going to be utilized to help us avail this space where a kind of a sun exposed surface or sun exposed area could be developed, where people can sit and can enjoy the winter sun if it is available. And this is going to help us develop some kind of landscape features as well, which can be utilized in those extreme areas. And preference is to have windows of larger scale on the south and the western side where extreme winters exist, so that maximum exposed area of the glass can be utilized to capture the sun during the daytime to keep the interior space warm using the green effect method. It's like a green room method, uh, and it can be very helpful. Sun exposure optimization for winter is very necessary. Sun movement through the day and through the year is one of the most crucial environmental factors to understand when designing high performance buildings. So we have to evaluate for how far and in which direction the sun is moving, which building site is having that much of exposure, and is our living spaces or optimizable usage functional spaces are on those sites or not. We can utilize the same mechanism as in the summers as well as in the winters. As you can see that utilizing some heavy materials or condensed material which have higher values to absorb the sunlight can be utilized in winter season to absorb the heat through the glasses, as you can see in the lower picture. And during the night time, if they are insulated, they are blinded, they have been enclosed, so that heat can be retained and will help to develop a comfortable temperature inside of the rooms which have been exposed to the sunlight during the day hours. Thermal mass can be utilized so that it can absorb maximum amount of heat and the solar gain can be done. And with the help of this, if it is insulated, the internal temperature can be managed and will be optimizably used during the night time and in the evening hours, so that it can be manageable, as well as will reduce your heating loads. This is how the overhangs can be utilized towards enabling that in the summers we don't get the direct sun coming inside, but in the winters when we need that, the overhang should be planned in such a way that the bottom of the window and the top of the window along with the shade is planned in such a way that the angles which are going to be optimized for the sun orientation can use the winter sun and can avoid the summer sun. With the help of passive solar principles, we can optimize them. These can be like having multiple directional spaces through let the in, and then can be utilized using alternate passive as well as active mechanisms in which heat insulation, the continuous air barriers, and other insulating materials can be utilized along with other active mechanisms like heating devices or centralized heating mechanisms can be utilized. Passive are the ones which are going to have comparatively better effects, and they are energy efficient. But on the contrary side, wherever the passives fail to respond to that to create that level of comfort, we are going to opt for the active ones to keep it working. Sunlight utilizing the trombe wall can be utilized for that. The airspace is going to get heated because of the glass on the other side, and across ventilation, the hot air is going to move in and the cooler air can be moved out with the help of exhaust fans, or even with the help of ample amount of surface area if it is managed, and can be utilized in a very good way. This is just like creating a solar room or a sunroom as we are creating on the top of the roofs these days in domestic houses or in the residential projects. Similarly, this surface can be created and is going to help us in the same way. This is another way of doing the same, utilizing a concrete wall or a stone wall on one end, and once it's going to get heated up, that get heat and that airflow could be managed to retain the inside spaces. We have to ensure that this mechanism is working and operational through alternate means or utilizing some mechanical means if it is necessary. Otherwise, these form of insulations once blocked, the internal heat or temperature can be retained for comparatively longer time if insulation is provided in a proper way. This is another way of doing the same, like creating a solar room along with the trombe wall. Both methodologies combine and can be very helpful, specifically in those areas where the direct exposed area is not exposed to the sun, or it is recessed inside, or the volume is comparatively bigger. So multiple spaces like these can be utilized on the south and the west side to enhance the interior space towards a comfortable environment. This is another similar example for the same, and this is how at the night it can be retained. Once it's closed, then the temperature is going to be, the disseminating factor towards the outer side will be comparatively less, where more of the heat will be retained inside. Is another way of doing the same. Alternates means an opposite of this thing can be utilized in the summer season, and the same can be utilized in the winter season for the optimization of temperature through utilizing some active and passive combination, in which over here we have got the sunlight collector, and since it's going to heat up this area, so it can be moved through this, and across air movement establishes with the help of some mechanical means, but we have to ensure that most of the area is insulated so that this efficiency mechanism could be achieved. Summer and winter suns, as already explored, with the help of deciduous trees can be utilized. In the winters, they are not going to have leaves on them, so they are going to be allowing sunlight to pass through the structure, whereas in the summers, as they are going to have a lot of leaves on them, and they are going to have a whole canopy, so it is going to block the summer sun penetrating. Insulation is wall and roof insulation is one of the key factors. Cavity walls, jumbolon, styrofoams, clay, even just creating a simple cavity, non-insulated space can increase this gap. Because what the purpose of this insulation is to reduce the transfer of heat energy from inside to the outside, because interior space have to be kept heated. So in a typical house, you can see that in the lower picture, 25% of the heat is going to be disseminated through the roof, while 35 from the wall. So these are the two major areas. Through the floor, it is very less, like 15%, through 25% through the windows and doors. If we can provide like double glazed windows, or the doors can be kept in such a way that we are going to have some blinds or some other barriers, and there are some cavity walls installed along with that, along with the roofing mechanism having insulation, so probably that will be a good mechanism to retain the heat inside of the spaces. This is how the thing would appear on the top and side. Front right elevation prior to cavity wall installation, that means most of you can see that this yellow part, as can be seen, is disseminating heat. But with the help of insulation installed inside, these walls have now been turned to purple. That means they are not disseminating heat, and most of the heat can be retained inside. So that is how a camera could be utilized, which is infrared detection camera, can be used to detect these kind of values and could be helpful. So in the design strategy, we have to opt for to resist the heat loss. So decrease exposed surface area, which is directly exposed to those cold sides like northern side or eastern side. Decrease thermal resistance. That means we have to increase thermal resistance. That means cavity could be added, thermal mass could be increased, and other solutions like having thicker walls or gaps and insulation materials could be utilized. Increase thermal capacity means with the help of increasing the thermal resistance, that means the capacity or the thermal capability of those internal spaces are going to increase. Increase buffer spaces, that means the heat has to transfer through buffer zones, so it will be retained still inside, and that could be easily managed. If we need to reduce the volume of the space, and we need to reduce the footprint, but it should not be reduced at such a rate that the functional needs are going to get sacrificed, that have to be maintained. Decrease air exchange rate, that means in the summers you need to ensure that the cross ventilation is happening so that it doesn't get humid, but in the winters you have to ensure that that exchange or cross ventilation is reduced to the maximum. But on the contrary side, there are some issues with that as well, because it is going to lead to fungus and molds and some other pathogens growth inside. So we have to ensure that multiple states, after like 1 or 2 days, they should be like, depending upon the size of the space, it should be circulated. It should be the cross ventilation should be achieved. Like and sometimes in winters we usually close the doors and open the windows and turn on the exhaust fans as well as turn on the fans, and that helps in the exchange of the air, and it becomes comparatively fresh, though it will be very cold for some time, for a few little time, but that has to be done. Otherwise the pathogens are going to grow inside, the molds are going to grow inside, and they are going to have issues, they are going to have impacts, and they will lead to issues of health, like breathing disorders, like skin disorders, or having irritation in the eyes. Those can be increased. Increase absorptivity, that means you are going to increase those areas which can absorb the solar exposure and the sunlight, just like glass, or we can add some water based elements, or we can add some stone based element or concrete based element which can absorb the heat and can transfer that inside. Double glazing can be utilized. Dark surfaces for absorption of heat is good. And then roof overhangs, main corporate roof and for summer time shading के लिए हम लोग utilize कर सकते हैं. Air circulation by convection or fan. House interior gains heat from sun space and returns cool air to the sun space. So that is a mechanism in which the air movement is usually going to be, since heated air is going to be lighter, so it will be on the upper end side, can be an inlet to let it in, and comparatively we can have some other outlet so that it can be transferred back, and a loop can be achieved once it's night time. So this is going to be covered, this is going to be insulated, this is going to be create a barrier. We can close this space and the interior space can have better form of temperature or a comfortable environment inside. Same goes over here. We have used the walls as well as the insulation in the floor so that the heat cannot be disseminated through the flooring and it can be managed. When we explore the thermal mass with respect to uh, retaining heat and utilizing thermal mass, brick is a good option, stone is a good option, water can be used as a good option, but timber or some other materials which are not very, which are not having higher density, they are not good for this purposes. These are like liquid thermal mass in which water can be utilized and they are going to absorb heat, and they're going to disseminate the heat in the later phase of the day when it will be night or in the evening hours. But these things have to be planned properly, these have to be efficient enough so that they are going to have retain the water quality as well as ensuring that uh, they don't leak. Apart from that, how they are going to be managed, but in our case, in our atmosphere, in our context, and the technologies that we are available at the moment, I guess the better option is to use the trombe walls or the stone walls, and the second best option probably is the solar rooms. They are really good and they create greenhouse effect and they will be very helpful towards enabling better performance. We can use the solar geysers for the same purpose as well. They are going to literal thermal mass के basis के ऊपर ही चल रहा होता है, तो इसका flow जहाँ जहाँ से हो रहा होता है या जिन पाइप से आप गुजार रहे होते हैं उसके थ्रू भी क्योंकि गर्म पानी आ रहा होता है, so those can be utilized for the heating purpose. In the cold climate, we are going to discuss a bit about the rural, urban, and suburban context. When we talk of the rural context, natural features dominate as compared to man-made features. We need to have respect for the site becomes critical because those natural features need to be retained. If they are not retained, that means that rural site is going to lose the true essence of it, and in that case, those assets of nature will not be available. We need to have respect for the site. Topography plays a very significant role because accessibility, transformation of the land, and respecting the topographical levels towards developing site are very important. Local context plays role of guidance and it has to be uh, predominantly utilized just like the vernacular architecture. इसकी example जो आपकी book है climate responsive design की रिचर्ड हाइट की, उसके पेज नंबर 35 के ऊपर इसके एक एग्जांपल को रेफर किया गया हुआ है, which is the rural context की जो सी एग्जांपल्स हमारे पास हैं, those are house at written by Lindsay Clare, and another one is the Mapleton House by architect Richard Leicester. So these two are some of those examples in which they have tried to utilize, yes, you can see the cantilevered surfaces providing some lorries or columns, and they have utilized some of the green structures and try to evolve the surfaces without cutting a lot of land or without utilizing or damaging the contextual site and respecting that. When we are talking about the suburban context, cross ventilation becomes a significant factor. Orientation of the plots have to be baseline so we don't waste the land. Solar exposure with reference to the neighboring build blocks and trees location have to be explored while we are devising and designing the spaces. Reflection from other building is another factor because we have to see that in the suburban context, we have got like pockets of built environment and a lot of green other open spaces would be there. So we have to see in which orientation we are going to provide windows and what kind of reflection and what kind of views are we getting. Privacy and local context also dominates, so it has to be there. The example is of a house retrofit in Brisbane, Australia, page number 37 from your book. When referring to urban context, we need to observe the buildings in macro and micro, both scales, mean in the bigger picture as well as in the focus site. At macro level, temperature, humidity, wind, and solar radiation becomes important. And now the micro scale, the density, the land coverage ratios, height of building, orientation, width of streets, subdivision of blocks, location of park green areas, they become very important factors. So the example is on page 39-44. So in a conclusion, climatic study along with contextual study baselines the design strategy. That means your context analysis along with the climatic conditions, they are going to help you devise what kind of a form, what kind of a building, what kind of features and what kind of materials and technological tools are going to be utilized to evaluate or build the new one. Design should evolve from the predominant conditions of site and context. That means doesn't destroy the context, doesn't destroy the site. You need to have respect for that. You need to evolve your site as well as your design through the site. We need to have respect for the context is a must which has to go so that the ecological footprint can be reduced of the build project or it can help in retaining and maintaining it. Human comfort and safety is highly important in design development and should be the focus of design. That means keeping the human comfort as well as securing that the structure is secure, safety is secured, and it's not an unhealthy building for the people to live in. And local technologies and systems need to be explored with conjunction to the modern applicable trends and choices in design. That means you have to think globally, but you have to act locally so that those technological advancements, which might be happening in some other parts of the world, can be seen, but how they are going to relate to our context, how they can be will be applicable to our context, and which technologies are available in the local context have to be explored to be ensured that they are going to have some better outcomes and better outputs for the projects which are happening within our context. So this is more or less, this will be your reference book, The Climate Responsive Design by the Richard Hyde. I hope you're going to soon going to get this book, inshallah, available, and you can have a look at them. Thank you very much for the session. I would like to have the LMS session for discussion on the lecture, and I would like everybody to go through the video and listen to it and ensure that you are available during the session time so that we can discuss. Thank you, everyone. Take care.